Hello, this is part two of graphing square root graphs and its translation. So let's start with y. We have y equals 5 square root of x plus 4. So let's start with the red is too dark. How about this red? Parent family, which is square root of x. So if we pick 3 points, 0, 0, 1, comma 1, 4, comma 2, you don't have to use these points. It's just 3 points from this graph. And then let's just do the add-ons. So let's use blue. Let's call this, I don't know, r of x. And then let's do 5 square root of x. So what does this 5 do? It is technically a stretch, I believe. Is it a horizontal or vertical? So it's outside. It is going to be it's a vertical stretch, right? But if you just have to know that when you have a number outside a constant outside the square root, all you got to do is multiply that y coordinate by that value. So 0, comma 0 will be still 0, comma 0 because you just multiply the y coordinate by 5, which is still 0. 1, comma 1 would be 1, comma 5. 4, comma 2 would be 4, comma 5 times 2 is 10. Okay. And then let's do the final one. Let's call it y. Let's use, what color should we use? Let's use green. Whoop, and that's bad. How about this color? Let's call it y equals 5 square root of x plus 4. So all you got to do, this 4 is a vertical shift. All you have to do is add 4 to the y coordinate. So it's 0, comma 4, because 0 plus 4 is 4. 1, comma 5 would be 1, comma 9. And then 4, comma 14. 10 plus 4 is 14. So yeah, let's see. I'm gonna graph this. I think I would graph this by using so let's plot zeros. Let's just graph each individually. I think that would be easier. So let's start with the parent graph y 0, 0. So 0, 0 is right here, 1, comma 1 is right here. And then 4, comma 2 is right there. 1, 2, 3, 4. Lock the points. So this is g of x equals the square root of x. And then let's graph the other one, r of x. So that would be 0, 0. 1, comma 5 is 1, 2, 3, 4, 5. And then 4, comma 10 is Okay, so this would look something like this. So we'll call this r of x is 5 square root of x. And then the lastly one is this one. So 0, 4 is right here. 1, 9 is right here. 4, 14 is 12. So this one would be y equals 5 square root of x plus 4. Okay, so that is this one right here is our final graph. And what would be the domain? The domain is from our smallest x values from 0. So it's going to be bracket 0 to infinity, parentheses. Our range, our smallest y value is, I believe it's going to be 4, right? So you start from here. So our smallest y value is 4. So it's going to be bracket 4 to infinity, parentheses. Okay. Yeah. So go ahead and write that down. Okay, let's move on to example 4. How much example? There is a total of, okay. So yeah, let's start with this one. This is y equals square root of 7 minus x minus 2. So, yeah, what would this looks a little bit off. What I'm going to do is actually rewrite this problem. Let's write it at negative x. Oops. Let's rewrite the inside the square root as negative x plus 7 and then minus 2, right? So what you're going to do is factor, I guess you could factor out a minus inside the square root. So this would be minus, and then this would be x minus 7, right? And then do you see this minus right here? Do you take it out? So you can rewrite this equation as y equals minus square root of x minus 7 minus 2. Okay, so let's use this one. This equation is definitely equivalent to this. And let's just do the add-ons. So let's start with the parent family. So we'll call it h of x square root of x. It has 0, 0, 1, 1, and 4, 2, right? And then let's just do each add-on. So let's call it r of x equals to square root of x minus 7. So we'll do the add-ons of the x minus 7. What does that mean? What does x minus 7 means? It means you have a horizontal shift of 7 units to the right. So basically you're adding 7 to the x value, okay? So 0, 0 would be 7, 0. 1, 1 would be 7. So you add 7 to the x value. So 7 plus 1 is 8, 1. And then You add 7 here, so 7 plus 4 is 8, 9, 10, 11. Okay, so 11 comma 2, this would be 8, and then 7 comma 0. Okay, now let's add, what color shall we use? Let's use now let's do graph. Let's call it g of x. Let's do the minus. So minus square root of x minus 7. So what does this minus mean? It means reflection across the x-axis. So if you have a number, so this is like an invisible -1. If you have a number or a constant outside the radical, you just multiply that. You multiply the previous y coordinate by that number. So 7 comma 0, you just multiply the 0 by -1, which is still 0. So it'd be 7 comma 0. 8 comma 1 would be 8 comma -1. 11 comma 2 would be 11 comma -2. Okay, and then let's do the final graph. Let's use red. Y equals minus x minus 7 minus 2. So what that minus 2 means is you shift it 2 units down. It's a vertical shift. So you just have to subtract 2 from the y value. So that would be 7 comma -2. 8 comma, so you subtract 2 from the y coordinate. So -1 minus 2 is -3, right? And then 11 comma -2 would be -2 minus 2 is -4. Okay, does that make sense? I'm just gonna graph. Yeah, let's just graph these. Okay, 7 comma -2 would be 2, 4, 6, 7, -2. So this is 7 comma -2. 8 comma -3 is here's 8. And then 11 comma -4 is okay, so this is your graph. So based on this graph, could you tell me the domain? The smallest x value, I believe it's going to be at 7 because that's our starting point. So it's going to be bracket 7 to infinity, parentheses. And then the range, keep in mind, we go from smallest y value to largest. So because it shoots down, it keeps on going down. So our smallest y value is actually going to be -infinity. And then we stop at the y value at -2, right? Because that's 7 comma -2, that's our starting point. So our largest y value or our most positive y value is at -2. And you do have to include it, so you use bracket. So this graph is this graph. Okay, let's move on. Let's do example 5. Graph and determine the domain and range in interval notation. Okay, so what do you think is going on here? This 3, you can't take it out because the square root of 3 is not a perfect number, so you have to leave it in. And then you have a plus 1. So this is this. What does that 3 represent? That 3 is a, if it's inside the square root, it is going to be a horizontal shrink or a horizontal stretch in our case because it is great. No, it's a horizontal shrink because the C value is greater than 1. And then this plus 1 is a vertical shift of 1 unit up. Okay. So let's start with the parent family. So let's call it h of x. So it's 0, 0, 1, 1, 4, 2. Now, what do we do with the 3? Do we add? It's not a horizontal shift. I believe we're just going to multiply the x value by 3. So yeah, I think you just multiply it by 3. So this would be 0, 0. This would be 3, 1, and then this would be 12, 2, right? So all I did was I multiplied the x value by 3 because it is a horizontal shrink. Okay, and then, well, so wait, this graph is y equals square root of 3x. And then, or I guess you could call it g of x. And then our final graph is y equals 3x plus 1. So this plus 1 is a vertical shift of 1 unit up. So all you have to do is add 1 to the y coordinate. So it would be 0, 1. If 3, 1 would be 3, 2. 12, 2 would be at 12, 3. Okay, let's start graphing. Zero, 1 would be right here. 3, 2 would be 12, 3 would be yeah, let's make 12 right here. So 12, 3 would be okay, so this is your graph. So what do you think the domain is going to be? Our smallest x value is at 0, and they include it, so it bracket 0 to infinity. our range is, our smallest y value is at 1. So it's going to be bracket 1 to infinity. Okay, so that's how I would graph these squared graph with translations. So just start from the parent family and just do the add-ons. Okay, I hope you find this video helpful, and I will end it here.